Good afternoon, everyone. I hope you had a good lunch. Everyone's ready and settled in for a good talk. Just the public service announcements that we've been making today. Please, if you're not using the wireless, if you can just disconnect from the network to give it a bit of a breather so that everyone who does need it can actually get an internet connection. Also, obviously, your usual housekeeping, mobile phones on silent, etc. Our speaker this afternoon has over 30 years experience working as a programmer and also conducts Python training throughout Australia and New Zealand through his company ++. And this afternoon he's going to talk to us about the dark corners of Python, which is not a fanfic conference. I'll hand it over to Peter Lovett. Please give him a welcome.
Thank you. Yes, where to start? Python's dark corners. This is the talk that I'd rather not give. The horror of the moment I shall never forget. So let's make a memorandum of what can go wrong. Just a tiny bit about me. My name's Peter Lovett. I have 3 decades of paid programming. Anyone here under 30? Yes, I've just in June clicked 30 years of paid programming. I've been running programming courses since '85, Python since 2007. That's my company. There we go. That's a bit about me. What else do I need to tell you? I like long walks on the beach, meeting people. Faith, hope and love. So, an overview of what we're going to be covering this afternoon is, what I'm covering is 2.x, although I will be giving you some 3-point tips. There's actually a couple of these dark corners that are solved in version 3. I'll be giving you the aims and objectives of each of the points that we look at. How to avoid them, that's the point. And at the end, I'll be taking quite whatever questions you have. So let me start up by saying I love Python. I've actually worked and been paid in languages of every letter of the alphabet, from APL to Z80 assembler. And I love Python. I still work in other languages, predominantly C++ and Python. Python is the language to know. If you only need to know one language, learn Python. C++ complements that really well, so I do quite a bit of work in C++, Perl, Java, etc. But I love Python. Python's my language of choice. It's a fantastic language. However, it's not perfect. And I'm often coming into companies that have lots of self-taught Python programmers, possibly like you. And I find that people, when they're self-taught, they learn the things they think they need to know really well, and there might be a few gaps in your knowledge. So my aim for this afternoon is to fill in some of those gaps, help you avoid some of the traps that I've fallen into and I've seen other people fall into. Python, I find, is a deceptive language. People that are self-taught look at Python and go, oh yeah, I get that. If, else, easy. I can do this. This is quite straightforward. C programmers stumble over the for loop, go, whoa, that's a bit weird. But generally, I can get a while to work, and but it's a deceptive language, because there's actually a lot of trickiness and a lot of cleverness in behind the scenes. So there is the thing that no one wants to talk about, the elephant in the corner. So what is the elephant in the corner? Not that elephant. That's Python sucks, 3.8 million results. However, don't feel bad. I gave this similar talk to this last year, and last year we were at 4.4 million. So we're really significantly improving, and certainly Python programmers shouldn't feel bad, because JavaSucks has over 10 million. And really, I've got to tell you, of that 3.8 million, you know, like 3.8 something million of them are, some people say Python sucks, but really, it doesn't. It's a great language. Let me show you something else about the dark corners. Now, anyone know what this is? It's a graph. Who said that? Yes, the man wins a t-shirt. Well done, an exclusive. It is a graph. Can I have a little bit more detail? It is a trading graph. Anyone know what it's of? No, it's the share price in blue and the volume traded in red of an American company called Knight Capital. This happened at the 1st, I think it was, the 1st or 2nd of August. Some of you might have heard about this. As programmers, we need to know about stuff like this. This company, Knight Capital, trade something like 10% of the volume of shares traded in the exchange that they work in America. Really big share trading company. High frequency trades equals software driven, equals algorithm driven. They had a technical issue and their program went wrong. Hasn't come out yet exactly what went wrong, and I don't know whether it was Python specifically to blame. Because it's high frequency trading, I'm guessing C++ actually. But this is what happened to the share price when they announced that they lost $440 million in half an hour. So I need to put that into us. You might not be doing high frequency trading, but all of us have jobs that use Python, and you might think that it's not that important, but it may well be very important. The phrase that needs to jump into our minds is, what's the worst thing that could possibly happen? This is very instructional because they discovered the problem within about 2 or 3 minutes, and there was no kill switch. There was no pull the plug. It just kept on trading and getting them into more trouble for half an hour. So let me put the fear of God, fear of programming into you. So, like I said, I know they use Python, but I don't know if Python specifically was implicated in that issue. So what we're going to look at is some aspects of Python. Everything's an object. It's only a name. Types, how to change an object's type. Important types, what's a constant. Accidental name creation. Surprising namespace rules. Arguments, and then questions. So firstly, everything is an object. Even built-in types. So, I is an object. I has methods and attributes. It's not a little, for my C programmers, it's not a 2-byte or a 4-byte piece of memory. It's an object with methods and data attributes. Let me just check actually, who, on the Python scale, who regularly uses Python? Yep, good. Who uses Python as your primary programming language? Lovely. And of those that don't use Python as a primary language, who uses C, C++? Good. Java, VB, assembler, yay. Okay, good. I is nothing like a C integer. Note that I could do things like get a directory list of it. The dir function is your friend. You need to know the dir function. Tells you all the attributes and the methods in there, gives you a nice list of them as strings. So if I've got a string like ABC, then ABC has a whole raft of methods. The dir on ABC. Actually, what I wanted to do was make that into an object. Everything in an object, everything in Python is an object. I can get a dir of that. There's a lot there. You can even get the type of an object. I looks like that. It's an object of type int. And the type of S is that it's a string. Everything's an object. Even functions. I go and define myself a function. P.S. If you're not used to using the interactive shell in Python, get used to it. I live here. This is like, I wonder what that does. Ah, that's what that does. Define a function. What does it do? Not much. So let me get a directory list. I didn't really do much on that function, but... Ooh. Sorry. I missed one extra enter. I hope my function is still good. No, that's all right. Luckily, I can do that. So a dir on function is, look at all the goodies that I got. Even a function is a object. Modules are objects. Import math, get a dir on math. Whoops. And run it as a function. There's a whole lot of stuff there. So everything's an object. But let me even jump forwards a tiny bit. Even functions are objects, modules are objects. I'm going to skip forward for a tick and come back to those other ones because I want to look at it's only a name. So if everything's an object, let me go and set A to be a list. And let me go and print A. That's what A looks like. Let me set B to A. If I go and append onto the end of A looks like Whoops. That's not actually what I wanted to do. Sorry. A is a list. Let me go and append the number 4 onto the end of A. A looks like that. If I've set B to A previously, what is B? What is B? The same as A? We've got a 1, 2, 3 or a 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. It's a crucial thing to know. This is not something to get mistakes on. I could actually find out if I could find out that doesn't even. Sorry, let me start. Let me go and yes, it was. Sorry. B gets A. A gets appended. A looks like that, and B looks like that. And the reason that it looks like that, or the way to tell, is not with the equals. Equals won't tell you whether that's actually really the problem. That will tell you that they have the same value. But what would really tell you that they are the same is. Python programmers have to know about is. Is used for do these references both point to the same object? And yes, they do. As a side note, you could play around maybe with the ID of those things. What's the ID of that thing that we are pointing at? And that tells me that they are objects. So let me go and set x to 1, y to x. Actually, even before I do that, x is 1. Let me go and say, what's the value of plus plus x? 2. Who said that? I'm going to give you a t-shirt. You're wrong. But, you know, I've got to encourage participation. Oh, by the way, this is Python. This is not C. There is no plus plus operator. There is, so people are going, oh, okay, so there's no plus plus operator. What's that doing? Well, it's really giving me the positive of x, which means that the minus minus of x would be the negative of the negative. Oh, let me ask you what's the negative of the negative of the negative of. Anyone? -1. Oh. Look, I had a 50% chance of getting that one right, so I just had a stab at it, okay? Can't. So there is no plus plus. Of course, x plus plus is a syntax error, invalid syntax. There's no plus plus. I'm jumping ahead of myself though, but this is the Python course, not the C++ course. Well, if x is 1, and I set y to x, now let me go and increment x. I know I can't do it with plus plus. So I'll do a x gets x plus 1, or for the enlightened amongst you, x plus equals 1. X is now 2. What is y? 2, 1, 2, 1. Look, this is, I hate to break it to you, this is really simple stuff. Like, you've got to get this right. If you get this wrong, you are just sunk. Maybe I'll break it down and say, what does that do? X plus equals 1 is really x gets x plus 1. Which really is x gets me a brand new integer with the old value of x incremented with 1. That's valid syntax. X is now 3. But when did y get changed? Well, it didn't. Why not? Because that is not changing x. Ints in Python are immutable, unchangeable, cannot be changed. You can't change an int, or a float, or a tuple, or a lots of things, complex number. Ints are immutable, so that doesn't change x. It makes the x pointer, for my C programmers, point at a new object with a different value. I could define this too and say, is x is y? No. The ID of x is that it's there, but the ID of y is that it's a completely different object. So you need to understand that every name is really just a pointer. It's an automatically dereferenced pointer. It's a reference. Well, if everything's an object, I can do the same with functions. The absolute value of -4 using the built-in is 4. Function points to ABS. So I can now get the f of -4. I could have myself a list of functions of f and ABS and duh, sweet. For each function in the list of functions, print me out the function of whatever. 4, and there's the dir of 4. So for my C programmers that are after an array of pointers to functions, I love Python. Just remember that everything is an object, and every name is just a name. It's just a name. Therefore, if I've imported math, if I've imported math, then that's just a name, so I could have a different name and do the m dot square root of -1. Anyone? Yeah, it's a domain error. However, if I'd used CMath for the complex number mathematics, then it would be a different answer. I would have got I. Or J, really, is the actual syntax. Cool, it's just a name. It's just a name. So, everything is an object. Built-in types are objects, functions are objects, modules are objects, user-defined types are objects. So I can go and create, me my own class. Call it, I don't know, whatever. And it will have a contents of, doesn't matter. But I can build objects of that class. C gets a new C object. Note this is not the nicest way to do it. This is module version 2. I should probably really be inheriting from object, but I can still do that. In Python 3, all classes automatically inherit from object, and it's still got stuff in it, even though I didn't actually really put anything in it. If that is an object, even a class definition is an object. For my Java friends that want a factory, let me create a factory that takes a class definition as its argument. And go and return build me a new object of that class. So I can now go and call factory, building me an object of this type. Everything's an object, even a class definition. Oops. It's a C class object. Everything's an object. We even have meta classes. It's worthwhile me just mentioning that everything is derived from object with a curious little switch that we can have meta classes which are actually derived not from object but from type. So it's only a name. Every name's a reference. We've had a look at those. The importance of is, don't get confused with equal, equal. It's only a name. It's only a name, but it's an important name. Let me go and create a string called, this is the Python course, so we'll call it Mr. Gumby. Anyone see my mistake? Well, I haven't made a mistake yet. I can go and print that string. I've seen this 1,000 times, right? No warnings, this is just normal, it's just a name. So let me now go and print the string, and on the end of that I'll print a number, that's fine. Actually, I want to concatenate the string and the int together. And as you know, you can't concatenate string and int objects. In that case, it's quite easy. I'll just go and call the string function. Now, I used to have a string function, but I don't know more because I rebound that name. That name that used to be bound to the function is now pointing to my string, hard-coded string. Is that a problem? I don't know, it's a dark corner though. coming up. The big question is, well, what do I do about that? There's one easy way: end of file, restart the interpreter, problem fixed. If you didn't have that option, then if that was bound to Mr. Gumby, then I could actually go and rebind that back to, well, you could go and rebind it back into the built-ins. So built-ins is a handle to the built-ins. However, built-ins is actually not standard, so that's working fine with the active state Windows build. It may not work on your build of Python. Instead, you would use built-in, except the curious thing about built-in, the built-in module is it's not built-in. So what you have to do is go and import built-in, and then you've got access to the built-in module, and now I've refixed. I'm not sure, because stir is actually not a function. I'm calling it a function, but stir is actually the constructor for objects of the class stir, so I think I would find it over there. It's just a name. So built-ins, plural is not standard, so you have to import built-in, which gets me to the lovely joy of going and setting true to false. Sure. Okay, so while true, print yay. What's the value of false? False. What's the value of true? False. True is false? Why, yes. Now, I would like to take a don't quote me on this, all right? I've just seen myself getting into a huge amount of trouble here. True is false? No. I would love to take that offline and discuss truth with you. What is truth? You can even assign to none. I thought it was funny. You could even assign to none. That was actually fixed in 2.7, so I can't show you that. I'm running 2.7.2. True and false become parts of the language in 3, and you can't assign to them in 3. Yay! It's only a name. So then the question becomes, well, how do I pass things to a function by ref? Well, it's easy to pass things by reference. They're always passed by reference. Everything's by reference. And I get one of you, I contract you out and say, oh, can you write me a function that does la la, and I pass you my list, and I'll cross my fingers and hope that you don't corrupt my list. How do I pass? By copy in Python. Everything's by reference, and there's a good reason for that. That just improves performance out of sight. If everything was by copy, we'd be in trouble. But how do we pass things by value? I'm glad you asked. Well, if you want to pass something by value, you're going to have to, well, you can't. You could always, though, go and make a copy of an object. So if I've got myself an object like A, and I've shown you that A can be a list, and if I do B gets A, that's not a copy, that is the same object. So how do I make a copy of it? Well, one way would be that I could build myself a new object, a new list, initialised from the same values as the, and just for the fun of it, -1. That's fine. C looks like A. In fact, C equals A, value-wise. But C is A. No, they're different objects, so go and append a 4 on the end of it. C changed, but A never changed. That's one way. That wouldn't be my recommended way. Well, it depends what you're doing, I suppose. I could build myself a new object. I could, because I know how to do a loop, I could do a loop. I could have myself, now this is for my C programmers, I have a counter. I keep on looping while the counter is less than the length of the list. And I go and remember that I forgot to create an empty one to go and append the ith element of A onto the end of. So I'll go and create an empty one to start with. And then I will go and loop and, where are you gone? Append. Am I missing anything? Increment I. P.S. This is not the way to do it. But even that's not the way to do it. You're thinking like, if you're writing Python code like this, you know, get out, you know, go to a Python conference, something, because that's just, that's not Python. Sure, it worked, but that's not Python. That's, you're thinking like a C programmer. I mean, at least if you did a, you know, for each. Remember, FOR is really for each. It's not a for loop, it's a for each item, for each thing, for each X in the container, the iterable, actually. Go and append X onto the end of that. That way I don't have to remember to not forget to do my incrementing. If you're using incrementing square brackets, gee, I mean, that's not Python. This is more Pythonic, certainly, but I wouldn't be doing like that. If you really wanted to do it a bit more easily, use the list constructor maybe, if you wanted to create a list. That would be an easier way. Although that does give me a list, assuming that I had a list, I'll get a list. If it was a tuple, I now don't have a tuple. Funny little one, I'm actually not a real huge fan of the syntax, but of course that works. Slicing creates a copy in Python. So, I'm not a huge fan of the syntax, but it actually creates a copy of the same type, which was nice. Some other alternatives are you could go and grab the funky syntax there. You could use the copy module, that's always another option, but watch out for how deep it's going, because it's only copying the top level. If you've got a list of lists, then maybe you want to do a bit more thinking, or maybe you want to use a deep, sorry, deep copy. Deep and shallow. How are we going? Anyone learnt anything? Awesome. Let's have a look at types. Objects can change their type. Well, by now that should be pretty obvious that the answer to that is no, they can't. I can make the str name bound to something different. I can make I bound to something different. I can make I equal to something else. I'm not changing I, I'm just making it point at a different object. That's normal, that's Python. That's the way Python works. They can't change their type, but you can make the name point to an object of a different type. Objects can't change their type. You can do some funky stuff with metas, but... Last point there is checking the type of an argument is probably wrong. I see people writing their functions going, oh, I've got to have a list here, man, so how do I test to see whether the argument is a list? Oh, how do I tell whether an argument is of type list? You don't want to. You want to see whether you can subscript it. You don't care whether it's a list, a set, a tuple, or something inherited from tuple. So checking to see, oh, what is the type of that argument is probably wrong. You should be avoiding RTTI, runtime type information. Maybe using has attribute might be relevant if you wanted to see whether can this duck quack. But really another way is just to try it. In other words, have a go at it. If it fails, then an exception gets thrown. Oh, that object couldn't quack. And you would have heard of Python's type mechanism known as duck typing. If it looks like a duck, walks like a duck, quacks like a duck, it's a duck. Well, it exhibits duck-like qualities. I don't really care whether it's a duck. Types part 2. Ints are not the same as they are in C. So what is, for my C friends, let me make I equal to 1, 2, 3 to the power of 100. Now let me make it harder. 4, 5, 6, 7, 8, 9, 10 to the power of 100. Anyone? I is, and if you weren't sure, it's got an L on the end. It's a long number. It's not the same as C. But what's 7 divided by 2? Got to know this. It's important. It's exactly 3. 7 point divided by 2 is approximately 3.5. Remember, this is not C, so watch out for things like that. What's minus 7 divided by 2? -3 is a C programmer's answer, or Java, or lots of other languages, but this isn't C, Java, this is Python. I think Python does it right, but it's doing it differently to other languages. Watch out for that. While I'm talking about types, watch out for floating point numbers. Anyone know what 1.1 plus 1.1 is? Oh, come on. Approximately 2.2, good, excellent, you're still with me. Plus 1.1, minus 3.3. Does it equal? Plus 1.1 minus 3.3. If you think it's 0, you're going to be sadly mistaken, because it's not 0. You win. That could be a problem in some of your code if you're expecting these to come out perfectly. This is not Python's fault, by the way. Exactly the same problem occurs in C, C++, Perl, Java, Visual Basic. They all suffer this. We'll blame, I'm going to blame the hardware guys, IEEE. They decided how base 2 binary computers would store floating point base 10 numbers. And there's a good reason to do it. They do it very efficiently, but you need to watch out for floating point numbers. If you don't know what's going on there, you need to check how floating point numbers work. If you want to get a bit more accuracy, then you could use the decimal class, which interestingly I noticed in 3.3 has been substantially improved in performance. So that gives you arbitrary length floating point numbers. Watch out for single element tuples as well. If T is 4, what's the type of T? It's an int. If T, if T is 1, 2, 3, what's the type of T? Tuple. Let me make it a short one. What's the type of T? You're too good. That's an int, correct. If I wanted to make it a single element tuple, you get this curious syntax, although it makes sense when you see it, of that, which changes its type. You could also use the tuple constructor if you were in the mood for that. What is a constant? I'll tell you what a constant is an immutable object. Ints are immutable. There are no methods in an int to change the int. What part of a tuple is a constant? The tuple is a constant. So T is a tuple, so if I go and append a 4 onto the end, there is no attribute append. If I try to make if I have a look at the first element, that's okay, but if I try to change it, you're in trouble. It doesn't support item assignment. But watch out for tuples like this. This is a tuple made up of a list and an int. So I can't change T0, but T0, I can go and append a 4 onto the end of it, even though T is a tuple. So watch out for tuples. What part of a tuple is a constant? If you want to create your own immutable type, the easiest way is inherit from tuple. You are creating an object because tuples are objects. Accidental name creation. The quick answer about this, is this a problem? Probably. You've got a program, doesn't matter what the program is, your variable, and if you're anything like me, and if you type like me, you go and, accidentally, what are you doing? You go and have a, function which is equal to whatever, but you go and mistype something. Then that goes and creates a variable. I gets 5. Let me go and increment I, but I accidentally. Now that's okay because you've actually got yourself an error there because there is no original value of the variable IO. So how do you solve mistype mistakes, as in typing mistakes in Python? Depends what tool you're using. I'm using a tool here which I'm a big fan of called PyCharm from JetBrains, the same people that brought you IntelliJ. And it's got some gorgeous things like an inspector. I ran this over my whole project and came up with a raft of sorts of problems, of mistakes, little minor. Other options, though, is to use things like PyChecker, PyLint. There's lots of tools to check for very minor mistakes. but they're definitely mistakes in your Python program. Ooh, not that one. Oh, what are you doing? Sorry, my mistake. Just lost it. Come back. Where was I? Python doesn't suck. Sorry, my mistake. This is my recap. Accidental name creation. There's no easy solution. If you can't spell, that's how you can solve those. My nearly last topic is arguments. This is a nice little program I got here with default arguments. I love default arguments in Python. Python's argument passing is the best of any language I've used. So we can pass arguments ordinally by position. We can pass arguments by name, even the wrong name, the wrong order, I meant to say. I can even have by, leave them all out, take all of the defaults. Of course, this would be wrong, because if I'm setting 11 into X positionally, ordinally, and trying to override it, then I'll get myself a type error duplicate arguments for that particular one. Arguments. Here's a nice little function using default arguments. Using default arguments, I've got the default argument of, I'll just have an empty list. This is a classic mistake in Python, the mutable default argument. The big question is, when does it create that empty list? Well, a def statement is a executable statement. So when that gets evaluated, that's when the single only mutable default argument, the list, gets made. It gets made once. And therefore, that actually preserves the value of that list between multiple calls to F2. Dark corner, chance of mistakes, I think so. It makes sense though when you consider def is a function, is an executable statement, but just it can give trouble. The easy solution to that is to use a non-mutable argument. The non-mutable argument of none is often used because if somebody was explicitly passing none to your function, they know what they're doing. Don't worry too much about them, they're okay. And I'm then binding that to a local argument L, so I'll get a new individual single argument there. So for that, see the docs. They have actually there's a very nice explanation of functions. A function definition is an executable statement. Which brings me to surprising namespace rules. Let's go and grab a program. Let's go and create a program. Let's go and create a function. Define a function, takes no arguments, and it goes and prints out I. I gets set globally to 5, and I will go and call function. What does this program print? Oh, how come he's getting claps? And it prints out 5. Yay. Good. So global variables are accessible inside a function. Let me go and change that to a 6. What does this print? Oh, guys, you are a genius. Let me go and after the function go and print out I. This prints 6 and then 5. Good. We're still with me. 6 then 5. Let me then print I. Set I to 6. Print I. No, actually, what I'll do before I set that, I'll print I. I'll print I. I'll change it. Then I'll print it. What does this print? For a T-shirt.
Unbound local error.
Oh, you already know. Undefined? I'll give you another one later. It's an error. It's actually called an unbound local error. The nasty little corner of Python. I think it's actually the right decision. This should be a mistake, and it is. It gives me an unbound local error, because what should this be? Should this be the global I or the local I? What would happen if that was in fact not a standard declaration, but a conditional assignment? If, then sometimes it'd be the global, sometimes it'd be the local. You'll actually notice from this that Python actually does forward scan through a function. So it actually has to know back then that it's doing something later on to that variable. Python's doing the right thing, but it's a cute little surprising namespace error. If you've come across it, you would have spent 3 hours searching Stack Overflow trying to find out what happened. That's what's happening. The thing that people often don't like was in fact that part. A lot of people don't like that. How come I can see a global variable? Well, look, I'll say what you should probably do is actually not have global variables. If you define everything into a function called, for my C programmers, let's call it main. You don't have to call it main. And then your main line then would become go and run the main. Oops, that should be over there. Then that solves my problems. I don't have any global variables, and that now gives me a proper global name I not declared. So that is what I would suggest for the unbound local error, and avoid problems by using a main line. You could use the global keyword. No, I'm not even going to show you how to do that. And checking tools and care. Which brings me to the end of the talk. Applaud now. Give me some more than they had. Thank you. Thank you very much. At this point, I feel like I haven't done it justice, but some questions. Question time. There's one up the back. I'm 42. I'm not. I'm 30. In hex, that is.
Can you explain how -7 divided by 2 is -4?
Yes.
And also the 1.1 plus 1.1 plus 1.1.
Yeah, that was cool, wasn't
minus
it?
3.3
Yes.
equals blah.
Yeah, that was lovely. Let me start with the floating point one, because that's that's actually the same as saying what is 1.0 divided by 3. And the answer to that is, well, I can't really tell you. I can only tell you an approximation of what that is. And that's approximately 0.33333333. Likewise, in Python, not in Python, but in base 2 binary computers, 0.1, 1/10 is actually not representable in a binary form. There's no base 2 form for a tenth. So it's actually 0.1, 0.0001, it's not quite exactly 1/10. They can't actually represent a tenth. Some decimal place ones we can represent, some ones we can't represent. That's one of the ones we can't represent in a base 2. So Python's floating point numbers use the same as C, which is doubles, double precision floating point numbers, which store 15 significant digits up to 10 to the power of 308. It's a big number and a lot of decimal places, but not enough. It's not infinite. So we actually can't represent 0.1. Now, in old versions of Python, if you did 0.1, it would come up 0.100000001. If you're running like a 2.4 or something like that, that's what you'll see. They're prettying up the representation now, but the fact is that we can't represent some floating point numbers. So there's inaccuracies occurring at the 15th digit, and that's what's creeping in. How do you solve that? Well, one way would be to round. So if I just, did some rounding of my numbers, then that could solve it. Round my numbers to a certain number of decimal places. I have 2 minutes left. The decimal class will also solve that. I can give you a nice example afterwards too. The idea about the -7 divided by 2 is that I can't remember the argument, but division's always a flaw, so it's actually following mathematic rules rather than computer rules. Computer rules say the sign is different and we'll just halve it. but so that other operations are actually work as the flip, it actually has to work like that. So Python is favoured by scientists and mathematicians. What's that? That's right, to make the mod of it add up. And yes, it's worthwhile noting that ordinary division is returned to proper in version 3. And so if you really want a floor division, you should probably be using floor division operator, which gives me exactly 3.0. Have we got time for one more question, or? That's the end of the show. Thanks for coming. I'm happy to hang around and give you some other examples.
Yeah, so...